Okay, this lesson will be about infinite series. So I've shown an example of an infinite series here. What it is a sum of an infinite set of numbers. Here the numbers are called A1, A2, A3, ... So this list of numbers goes on forever. And to form the infinite series, we're going to take all of these numbers and add them all up. So we want to know how we can make sense of such an infinite sum. So the way to do it will be to define what's called partial sums. So to define these partial sums, we'll choose some number capital N, and we'll define the partial sum S capital N to be this infinite series restricted to the first capital N terms. So we take the sum of A1 plus A2 plus ... but only up to A sub capital N. And by studying these partial sums, we'll be able to understand this infinite sum that defines the infinite series. So our main question is then, what happens as this capital N is taken to infinity? So what happens as we increase capital N? There are several different possibilities. The first possibility is that Sn grows without bound. So increasing capital N just means we keep adding more and more terms to this sum. So in this case, the sum is growing without bound, and eventually it grows off to infinity, and we say that the series diverges. The second possibility is that these Sn's tend to a fixed finite value. So Sn tends to a fixed finite value, and we can call that value S, and in this case we say that the series converges. So as we keep adding more and more terms, Sn approaches this fixed value that we called S. And these are not the only two possibilities. There are other possibilities. We won't go into detail on these other possibilities here, but basically what can happen is Sn keeps alternating between two different finite values. So it doesn't diverge, but it also doesn't tend to one fixed value. So to finish this lesson, I just want to show you two examples of series, infinite series. And in the first example, the series will diverge. And in the second example, I'll show you a famous example of a convergent series. So the first example is this series. We have the sum from 1 to infinity of 1 over n. So this is equal to 1 plus 1/2 plus 1/3, and on and on. In our notation above, we take an equal to 1 over n here. And this series actually diverges. It grows without bound. So this is a simple example of a divergent series. Now, the next example is a famous example of a convergent series. And what's this example? It's the sum from 1 to infinity of 1 over n squared. So this is equal to 1 plus 1/4 plus 1/9, and so on. And this series actually converges to a fixed value S, like in our notation above. And this s is actually equal to pi squared divided by 6, which is a very interesting value. So this problem is actually a very famous problem in the history of math, trying to determine this value, and this problem is known as the Basel problem. And it was solved by a very famous mathematician, Leonhard Euler, who was one of the greatest mathematicians who ever lived. So this is a second example of a series, and in this case it's a convergent series. And just to complete filling in all the details here, in our notation above, in this case we have an is equal to 1 over n squared, and this series converges. So that's the end of this introduction to infinite series.